Yep. Here we go. Okay, so here we go. You ready, Austin?
Yeah.
Okay. Everything okay? Excited to be back to math
Yeah.
class? Yeah. All right, so here we go. So our factors are x plus 3, x minus 4. Okay, now I always have to write these down. I have x equals 2 minus I, and then x equals 2 plus I. So my factors are going to be x minus 2 plus I. Remember, you're moving everything over here with the x. And then x minus 2 minus I. Now there are other ways to do this, but the other ways require you to remember some things, and I have found that by the time the semester exam rolls around, you can't remember. So it's easier just to do it the way we do it. So we'll FOIL these two together. And then we'll FOIL these two together, and it doesn't take that long. And a whole bunch of stuff is going to cancel out. All right, so here we go. What do we have? X squared. That should cancel. That should cancel. And what did we say negative I squared is?
1.
Plus 1. So we have x squared minus 4x plus 5.
Yep.
Now we FOIL one more time, big FOIL. So I do this times all 3, this times all 3, that times all 3, I don't care how you do it. Make sure all of these are getting times by all of those. And then I'm going to rely on you to check me. Let's see. Don't just copy mine down because it could very well not be right.
That's what I got.
That's what you got?
Yeah.
Then we're right. Let's put y equals in front of it. Or f, better yet, f of x equals. Then it'll be a polynomial function, and we are good to go. Now, that is a bit on the tedious side, but there's nothing hard about that, right? I mean, it's tedious, but and you can make mistakes in it for sure, but it is not hard. All right, now we've got a big ugly polynomial. And we need to find the zeros, and this one stipulates no calculator. Now, the one Emma or somebody asked about earlier from the homework, we exhausted, I looked at that later, we exhausted every possibility, and then the only thing left to do was to go to our calculator. So I hope that doesn't happen with this one, but we're going to find out. So 5 answers we're looking for. PRRs, I'm just going to do those in my head. It's 1, 2, 4, and 8. Right? Spring, you're not on your phone, are you? No. Okay, good. And you're not on your watch, are you? No. Okay. All right, so who sees something? Do they found something that works yet? -1, I heard somebody say. Again, nothing hard here, but this is, oops, I don't think that's going to work. Unless I made a mistake. 4 works. somebody in the peanut gallery says 4 works, so we're going with 4. And 1 works. Well, wait a second, I can only do 1 at a time. So there it is. Good job. Good job. 4 worked. You may have found a different number that worked. Just find a number that works. So, we got x equals 4. Now, where I'm at, because x equals 4, I am left with x to the 4th plus x cubed minus x squared plus x minus 2. So what do I do now?
Another one?
Pick another one. And I heard somebody say 1 works, so I'm going to go ahead and divide out 1. Now remember, when I divide out 1, it's coming out of my depressed polynomial. Don't go back to the original, because you already took the 4 out. So go back to the depressed polynomial. And sure enough, it works. So another one of my roots is 1. And now I'm left with x cubed plus 2x squared plus x plus 2. Now, could I do it again?
Yeah.
Now, if you did you notice the set of numbers down here? See how they're all positive? What does that mean? 1's an upper bound. Don't pick anything bigger than 1, right? Because 1's an upper bound. But, did you also notice the factors by grouping? So, factoring is always faster if you can see that it factors. So, if we take out an x squared, we have x plus 2. And a 1, we have an x plus 2. So, another number that would have worked is negative 2. Alright, so another number is negative 2. And what's going to come out of this? Plus or minus I. So remember the original polynomial was 5th degree? We needed 5 answers, we got them. Right? We got them. What are the linear factors? Well, the linear factors would be x minus 4, x minus 1, x plus 2, x minus I, and x plus I. Okay. All right, let's look at this next one. This next one is an interesting one. We got a couple of different strategies, and honestly, I'm not sure which one would be the best. So what do you think? We've got this polynomial. And how many roots does it have? And we already know, though, that one of them is 1 minus 2i. So what else do we know? 1 plus 2i.
This 4th, on
Yep.
my paper it says 4x to the 4th.
Oh, what did I write? Oh, yep, that would make a huge difference, so thank you. What are your thoughts on that? What do you think of? If you're stranded on a desert island and you don't get to get rescued unless you solve this problem, what are you going to do? Maureen?
I mean, it doesn't really have anything to do with using 1 minus 2i or 1 plus 2i. I would just do the same thing I did.
So you would just start picking numbers and dividing them?
Yeah.
Right? Okay, let's talk about that. First of all,
Oh, wait.
is that acceptable? Yeah, perfectly acceptable. Is there any guarantee that any of the ones she's gonna find are gonna work? They might, hopefully they will, or they would for your sake, because your guesses are gonna be a little awkward because factors of 65 over 4 include a lot of fractions. Maybe you'll get lucky, but this is 5 times 13, isn't it? Yeah. So, yeah, you're gonna have like 13 fourths and 5 fourths and 5 halves and 13 halves. But that's an option. That is definitely an option. Can anybody think of another option? Oliver?
Could you try to plug the existing zeros back in? So like x minus 1 minus 2i.
So
And then
you
try to-
mean put this in here?
Well, I mean try to eliminate the I and get it so that you have a factor that's like x squared.
Oh, so you mean multiply these two factors together?
Yeah.
Okay, we can do that, and there's a place to go if we do that, so let's do that. So we've already done this, maybe with these exact same numbers, actually. I don't remember, they look very familiar. But Oliver is saying, this I thing is bothering me, so I am going to multiply my linear factors together. And I know what will happen, the i's will cancel out. Now, we need to talk about what we're gonna do after that, but let's get the i's canceled out. And Marin, I do not wanna sell your answer, your idea short. It's a possibility,
Yeah.
okay, definite possibility. Okay, so Oliver says all the i's have to be gone. 2ix, 2ix, 2i, 2i, plus 5, how does that look to everybody? Does that look about right? Now, I want you to think about this for a second. We know that these are factors of this, right? So the situation is similar to, you have a big giant number, and I tell you that 2 is a factor and 3 is a factor. So what you just did was multiply the 2 and 3 together. Now, if those are both factors, then 6 would be a factor, right? And what does it mean to be a factor? It means you divide it in and it goes in evenly. So if I were to divide Oliver's problem into this problem, and I notice I'm missing a cube if I copy it right. Put that in there. And I shouldn't have started clear down here. But if I divide that in, I can't do it synthetically because this is a quadratic factor. If I divide that in, the remainder should end up being 0, right? And what I'm going to have left up here, think about it, an x squared into an x to the 4th is going to leave me with what kind of quotient?
A quadratic.
X squared, which is quadratic, which is solvable, either by factoring or with the formula, right? So here we go, we're going to do long division. Remember how to do this? I hate it, but we'll get through it, it's okay. X squared, what does it take? What do I have to put up here to multiply times x squared and get 4x to the 4th? 4x squared. There is no rule that says you have to write it clear over there, but I am kind of anal and I like to have everything lined up. So I'm going to put my 4x squared up there, and now I'm going to multiply it times all of these. Is that all right? I took 4x squared times all of these, lined it all up. Now what do I do? Subtract. So subtract, subtract, subtract. And that's going to leave me with 8x cubed minus 3x squared plus 14x. So now I'm going to start over again. What do I take times x squared to get 8x cubed? 8x. One more line down here, so that's going to be 8x cubed minus 16x squared plus 40x now I'm going to subtract. And I'm going to get 13x squared minus 26x, and then bring down my 65. So now I need, what do I take times x squared to give me 13x squared? Remember, this is 13x squared number. So what do I have to take times x squared to get that?
13.
13 plus 13. And if I take 13 times that, don't I get exactly this? So when I subtract, I get 0.
Yep.
Now, what's left? Well, 4x squared plus 8x plus 13. Which doesn't factor. So Marin, I kind of cheated because I knew what was going to happen. So you could have started guessing all those options and none of them are going to work because this is going to be irrational or imaginary, one or the other. So x equals negative b plus or minus the square root of b squared minus 4ac is going to be imaginary. Negative 144. Goodness, this problem is like huge. So negative 8 plus or minus 12i over 8, which is taking out a 4, negative 2 plus or minus 3i over 2. So go back to the original situation. We had this big thing. We knew one of the roots was this. We also then knew automatically one of the roots was that. So we chose to multiply those together and then divide that into the original, knowing it was a factor, and I would end up with a remainder of 0. What was left was a little quadratic that then we solved, and here are the other two answers. Zoe?
So the answer, do we have to write the conjugate or no?
Yes. Yep. Yep. Now, I want to point something out. I don't know if you've done this before or not. This is fine. This is absolutely 100% fine. It will always, always work. It is a lot. Any way we do this problem is going to be a lot. But I do want to make sure you know that it is possible to do synthetic division with complex numbers, with imaginary numbers. So if you wanted to do it this way, and again, any way we do this is going to be a mess, so it doesn't really matter. But since I know that one of my roots is 1 plus 2i, you can actually do synthetic division with complex numbers, and it works the same way. So you're going to take 1 plus 2i times 4. So that would give you 4 plus 8i. You're going to add them. Now, this is where it starts getting messy, because now you got to multiply this times this, and that's going to be a FOIL that you're going to have to do over to the side. But this will work. And then once you got that one divided out, then take your answer and divide out the other one. And then that would leave you with the same quadratic that we got. So you can do it either way. I don't know what, you know, it's all a lot. It's a big problem, no matter how we do it. But both of those options will work. So, long division, synthetic division with complex numbers. All that's possible. Okay, I'm going to stop right there. Tomorrow we have a quiz, and then we will finish 2-5. And hopefully start 2-6. And part of 2-5 because all of it's included.
So this will be on the list?
Probably not something